Okay, in this lesson we're going to be doing scientific notation problems, and scientific notation makes use of those exponent rules with base 10. And so I want to talk about being able to, what you need to be able to do is convert between standard form to scientific form and back and forth, and then we're going to be able to work with multiplying and dividing numbers that are in scientific form. So we need to kind of get used to the notation here. So I've started out with a couple problems here that have two different scenarios here where we have a number in standard form. We're going to write it in scientific form. I'm like, what the heck is scientific form? So I'm going to move my decimal. This is actually 35 10,000ths. And so I want to write this in standard scientific form where I move that decimal 3 places over. So I'm rewriting that number as 3.5 times 10 to the negative 3. So we recognize what this negative 3 means. It means that this base of 10 is in the denominator, which would make this a really small number. Okay? We have a larger number like this, 341,000. We've got an implied decimal back here that we're going to move back 1, 2, 3, 4, 5 decimal places. And we're going to land here between the 3 and the 4 and rewrite this as 3.41 times 10 to the 5th power. Okay, our original number was a really big number. And so we have a positive exponent because 10 to the 5th means this would be 100,000. So we can see that positive exponents mean big numbers, negative exponents mean really, really small numbers. So a lot of times students, a lot of textbooks tell you to memorize that you move right or left so many places, and so you have to memorize if you have in standard form and you're going to scientific form and vice versa. And anytime you're memorizing, you're going to confuse things. So I really want you to memorize, not really memorize, but I want you to understand that a negative exponent means a really small number because that's 1 over 10 to the 3rd power. So when I show you this chart, this line up here, 10 to the 3rd power means 10 times 10 times 10, which is equal to 1,000. Whereas this chart kind of follows through, and again here you've got 10 to the 0 power is equal to 1. 10 to the negative 1 is 1 over 10, or 1/10. 10 to the negative 2 is 1 over 10 squared, which would be 1/100th. This would be 1,000th. So you can kind of see the decimal movement here. And we kind of had something, we dealt with this when we were dealing with moving from different forms of the metric system. We were basically moving our decimal. So we've done this a little bit before. Again, I want you to keep in mind that you're just moving the decimal. Now keep in mind this is huge right here. How do you know when to stop when you start moving that decimal? You move so that there's only 1 digit to the left. Do you see here in each of these numbers that are written in scientific form, we stopped so we had only 1 digit to the left. Okay, so that's huge. So we're going to practice a couple of these. This first row, we've got really small numbers. Okay, so we're going to be moving this decimal 1, 2, 3, 4 places to the right. I really don't care that you memorize to the right or to the left, but I do want you to recognize that our original number was a really small number. So we knew we moved it 4 places, but because that's a really small number, we know that that's a negative 4. So 5.17 times 10 to the negative 4. Here I've got 800ths, but I need to rewrite this as in scientific notation, so I'm going to move 2 places and write that as 8.0 times 10, and that was a really small number. We moved 2 places, so it's a negative 2. Our exponent is to the negative 2. Here, again, really small number. So this is going to be 6.2, and I'm going to move in 3s here. 3, 6, 9. So that'd be times 10 to the negative 9. That way I didn't have to count all my little movements. Okay, these next numbers, these are big numbers to begin with. So we know these exponents are going to be positive exponents. So there's an implied decimal back here. And again, I'm going to move in 3s. 3, 6, 7, 8. So this would be 5.23 times 10 to the 8th. And that's a positive 8 because that's a big number. Positive exponents are big numbers. So here we have an implied decimal here. We're going to move it back 2 places. 4.25 times 10 to the 2. We move 2 places, and it's positive because that was a bigger number than what we've written here. This, I'm not moving at all, but I'm just going to write it as 3.0 times 10 to the 0. We had 0 movement. So again, that's another place where you use that 10 to the 0. Okay, here we've got numbers written in scientific notation. We want to write them in standard form. So zero in on that power. That's a positive number. So that means I have to come back here and move that decimal in a direction that creates a bigger number. So I'm going to rewrite 6893. My decimal was here, and I'm going to have to move 7 places, but in the direction that creates a bigger number. So 1, 2, 3, 4, 5, 6, 7, and then fill in with zeros here. So this would actually be 68,930,000. This one here we have 9.0 times 10 to the 6th power. Again, we need to move in the direction that creates a bigger number. So my decimal is here, so I'm going to move 6 places to the right. 1, 2, 3, 4, 5, 6. I can put commas in here if I want. So this is actually equal to 9 million. Okay, and I moved in the positive direction because we had to the right because we had a positive power. Now I do want to point out these 2 things here. A lot of times students confuse and say, well gosh, you know, it's 6th power here, I have 6 zeros. I just automatically plug in however many zeros is that exponent. That's not always the case. That was the case because I had no other number after the 9, so 0 was one of my place values that I was moving across. Whereas here, after the 6, I started moving to the right. The 8, the 9, and the 3 were actually part of my, they were one of my 3 of my place values. So it's not always tucking in a bunch of zeros to equal the number of whatever your exponent is. So just be careful of that. It's movement across place values. So here I've got 2, 3, 5, 6. My decimal was here. I'm moving 2 places to the right. So this is equivalent to 235.6. Written both in standard form and in scientific notation. Okay, so here we've got really small numbers because this whole row is all negative exponents. These are small numbers. So I'm going to start out writing my number, and I've got my decimal here, but I'm going to move in the direction that creates a smaller number, that number of place values. So that means I have to go to the left, create smaller. 1, 2, 3, 4, 5. And plug in with zeros here and a decimal there. Okay, so the negative means go in the direction that creates a smaller number. I've got to the -2 here, so I'm writing down my 316. My decimal was here to begin with, and I'm going 2 places to the left to create a smaller number. Same thing here. I've got a decimal here, but I need to move to the left 3 places to create a smaller number. 1, 2, 3, 4, 5, 6. So I really wouldn't have to have that 0 there, but this is basically saying 9 millionths. Okay. Again, I did not, tell you to memorize, go right or left. It's understanding the negativeness or positiveness of the power. Okay, here we've got situations where you're multiplying 2 numbers that are already in scientific notation, and here you've got a situation where you're dividing numbers that are in scientific notation. I want to show you how you can apply the mathematical logic, but I do know that for the most part you would probably do this on a calculator. So we've got something times something times something times something. It doesn't matter what order I do that in. I could multiply these 2 together and then multiply these 2 together. Okay, using my regular multiplication, I'd probably go to the calculator and plug in 3.2 times 5.2, and I would come up with, I believe, 16.94. Then using my skills that we practiced in the previous video, where you are multiplying like bases, you collect the exponents. That would be base 10, and I'm collecting my exponents 3 and a -2. It would make that 10 to the 1st power. And you're thinking, great, I've got it done. I've got it in scientific notation. But do I? When I look at this first one, the first number here, I have too many place values to the left of the decimal. So I'm going to have to move this decimal 1 place value back to the left to write that as 1.694. My original number was a bigger number. That means I have to add 1 to that power there. So this movement here implies that I need to do that there. So that's 10 to the second power. I'm going to explain how you can do this on the calculator. I just want you to understand mathematically what happens. Okay, here I have something times something, divide by something else by something else. I can carry out and simplify that division and then carry out that division. So 7.2 divided by 1.8 on my calculator actually comes out pretty nice. It comes out as 4.0 times 10 to the, and here I'm subtracting, so that would be 10 to the 4 minus an already negative 3 would be to the negative 7. And so I could, I'm sorry, that'd be to the positive 7 because that adds to make that positive. So this would be positive 7. Okay, we could continue practicing all of these, but again, I know that you're going to do it on the calculator. You could do it on the calculator. For the most part, students who deal with this are going to be working in a lab of some sort or doing some kind of physics or chemistry calculation where you might need to do this. I don't see this happening very often in technical fields, but I did want to make sure that I pointed it out to you. So when you do it on the calculator, I think your biggest thing is being able to read your screen, your outcome. So I'm going to turn this on. Hopefully you guys can see this. I'm going to create a weird problem. So I'm going to put 0.000045 times 10 to the 0.000089. I made something really big. So I'm going to hit enter, and I want you to be able to see that. Do you see how we have 4.005 times, it'll be to that negative 12. And a lot of times students are like, what the heck, my calculator is, messing up. It's not giving me my answer. Basically what's going on here is you have too many place values that your calculator cannot display all of the place values. So it's automatically writing your answer in scientific notation. So you need to recognize that this is a really small number. That really, if you're going to write this out longhand, you would take that decimal and move it to the left 12 place values. Okay, so that's that calculator. I have 3 other calculators here that I want to show you the different types of displays. So this one, I entered a really big number division problem in here, multiplication problem, and this came out to be 3.3208 times 10 to the 17th. So this is a really big number. So you would basically have to take that number, that decimal, move it 17 place values to the right to get your huge result. So I just want to make sure that you know how to read your calculator display. Your calculator did not have enough digits, it didn't have room to put all the digits on its display. Okay, so another calculator that I have, I did a problem in here where I was multiplying really big numbers with lots of place values, and I got this outcome. I've got all these place values, but then I have this e to the negative 7. A lot of times students will look at that and say, oh my gosh, is my calculator saying I've got some kind of an error or something? It's wanting to let you know that it's got an exponent of negative 7. So this is a really small number. This is how your calculator displays scientific notation. So this is a really small number because that's a negative 7. You would have to take this decimal and move 7 places to the left. So as much as anything, it's learning how to use and use your calculator and then read the display. And every calculator, you could enter things in scientific notation, but every calculator is going to have a different algorithm for that, or different process. So that's not the point that I want to get across here. It's reading your display.